which I've done by mushing everything up a little bit to the top of the board. So in other words, our parent's budget constraint now, right, is a function of the consumption and the parent's investment in the child, but their preferences are a function of consumption and the child's future income. So in order to understand the parent's decision, we really like a budget constraint in terms of consumption and the child's future income. The way that we're going to do that is by solving for yt here as a function of it plus 1, right? So that we can substitute in a function for it plus 1 for yt here, and then get a new budget constraint that way. So essentially all we're going to do is take this equation, solve for yt, which we can do, right, by subtracting off these left terms onto the other side. So we can essentially say it plus 1 minus et plus 1 minus mu t plus 1 is going to equal 1 plus r times yt, which is going to mean that yt is going to equal this whole thing, it plus 1 minus et plus 1 minus mu t plus 1, all over 1 plus r. Make sense? Then we can put this in for yt here. So we can say it equals ct plus it plus 1 minus et plus 1 minus mu t plus 1 over 1 plus r. And then, this is a budget constraint, but it's ugly and I hate it. So I'm going to turn this into a more standard looking budget constraint, where we're going to have our goods on one side and our income on the other, by adding et plus 1 plus mu t plus 1 over 1 plus r to both sides. So then I'm going to get ct plus it plus 1 over 1 plus r, it plus 1 over 1 plus r is going to equal it plus et plus 1 plus mu t plus 1 over 1 plus r. And this beautiful thing here is our parent's budget constraint. So let's think for a moment about what this is telling us, right? And I want you to think about this by remembering, I know we're diving back into 250 with this really complicated model with a lot of stuff, right? But think about what our budget for apples and bananas would look like, right? We would have price of apples times the number of apples plus price of bananas times the number of bananas is equal to our total income, right? This is exactly the same thing that we have here. We're saying we've got two goods, consumption now, child's future income. The price of consumption now is 1. The price of our child's future income is 1 over 1 plus r, just like the price of apples and the price of bananas. Then the last thing is our income, and what we're saying is our total resources as a parent, right? The total resources we can devote either to our family's current consumption or to our child's future well-being consists of 3 things. It consists of my income as a parent that I can distribute between consumption and investment in my child, but it also consists of my child's future earnings that don't depend on what I do, right? It also consists of my child's talent, social connections, good looks, whatever it is you say that's going to improve their earnings, plus the ways that I expect them to be advantaged in the future in ways that don't have very much to do with me, right? Combining these 2 things is essentially my child's luck, my child's future earnings if I didn't invest anything in them at all. So I'm essentially going to say, what are my resources today are going to be my income today, plus my child's future earnings without me, discounted by 1 plus r, because they're only going to be realized in the future, right? So $1 of my income today is worth as much as that future earnings divided by the interest rate. Make sense? The same way that future income for my child is cheaper because of the presence of the interest rate. Okay, wonderful. So this is just the same sort of budget constraint as something with apples and bananas, just with this extra term. And the way to think about this is to think that when I know that my child is going to be better off in the future without my intervention, that makes me feel richer when I'm deciding how to allocate resources between consumption and my child's future income today. Awesome. So to make this clearer, right, and to make this connection between an ordinary budget constraint and this strange intertemporal parent's decision-making budget constraint, let's graph this thing. Just like any other budget constraint, we can graph this with consumption today on the horizontal axis, my child's future income as an adult on the vertical axis, let's think about what this budget constraint is going to look like. Well, the maximum my child's future income could be, right, is this thing here, times 1 over 1 plus r, or times 1 plus r, right? So the maximum this could be would be 1 plus r it plus et plus 1 plus mu t plus 1, right? Or, how about the maximum consumption I can have today? Well, this is actually going to be in a way a little bit simpler. Because while I can treat my child's future income as resources available to the family, we might want to assume that I'm not able to take out credit card debt in my child's name, or in other ways, convert this future income for my child into resources that I can consume today. In other words, we might want to assume that the maximum amount that I can invest in my child is 0, right? The most I can do is fail to help them in any way. And if that's the case, then the maximum consumption I can afford today is simply going to be IT. And if I choose consumption of IT today, my child's going to end up with ET plus 1 plus mu t plus 1 as their eventual income, right? IT plus 1 over 1 plus r would equal ET plus 1 plus mu t plus 1 all over 1 plus r. So I'll end up with a budget constraint that looks like this. What's the slope of this thing? Well, it's going to be the price of the horizontal good over the price of the vertical good. The slope is going to be 1 over 1 plus r, or more simply, it's just going to be 1 plus r. What does this mean? It means that every unit of consumption, every dollar I consume today, is going to cost 1 plus r in terms of my child's future income. Right? Every dollar that I contribute to my child's future income costs 1 over 1 plus r units of consumption today. Beautiful. Great. So far, right, we found our budget constraint. It's beautiful. We've graphed it. It's lovely. All we have left to do is figure out our favorite choice on the budget constraint given our preferences. Right? In other words, we just have to maximize our utility subject to this constraint. So how are we going to do that? Well, you might remember that essentially what we do when we maximize utility is we say each point along our budget constraint corresponds to, is on a particular indifference curve, right? And our goal when we maximize our utility is to be as happy as possible, which means to be on the highest indifference curve possible, right? So when we've maximized our utility, we should be at a point like this, where everything above our indifference curve is unaffordable to us, right? Isn't feasible, and everything on our budget constraint, other than our choice, is below or on our indifference curve, right? In other words, there's nothing else we can afford that we like better than point A, so point A is our favorite. How do we get a choice like this? Well, if it's going to be what we call an interior solution, right, which is to say that it's a choice like A, where we could, if we wanted, get a little more consumption or a little less consumption at exactly the same cost, we're going to have two things. We're going to need to have that the slope of our indifference curve is equal to the slope of our budget constraint, right? The slope of our indifference curve is our MRS. Which is going to mean that our MRS, in terms of CT and IT plus 1, has to equal our price ratio, which we said is 1 plus R. And why this has to be true, right? Because if our slope was different, like it is at point B, then that means that our indifference curve must cross our budget constraint, right? If our indifference curve crosses our budget constraint, there's something that's above our indifference curve and on our budget constraint, right? So this is the first thing. Slope of budget constraint has this equal slope of indifference curve. If it's been a little while, the slope of our indifference curve is our marginal rate of substitution, which tells us how much of our child's future income we're willing to give up for consumption today. So how should we think about this? Slope of our budget constraint is the amount of our child's consumption we have to give up to get one more unit of consumption today. MRS is the amount that we're willing to give up. If those two are equal, we're not going to be able to make ourselves better off by either getting more consumption or less consumption. Nice. So that's the first condition. The second condition for an interior solution is that we have to actually be on our budget constraint, right? We have to use all of our resources. There might be some point like C, where the slope of the indifference curve is also equal to the slope of our budget constraint, C sucks, right? Only a loser would pick C. We could do much better by using up all of our resources. There might be some point like this, D, right, where the slope of our indifference curve is equal to the slope of our budget constraint. D is awesome, right? We love D, but we can't afford it, right? Pie in the sky. No way. A is where it's at, right? So the second thing is we've got to be on our budget constraint. Make sense? Wonderful. So let's start with our first condition, right? MRS has to equal price ratio. We'll start by finding our MRS. So as you might remember, our MRS is just going to equal the ratio of marginal utilities between our horizontal and our vertical good. du dct over du dit. In turn, du dct, because we've got a Cobb-Douglas utility function, is just going to be 1 over ct, right? Because the derivative of a log is just 1 over the log, and then this term here doesn't have any ct's in it. And du dit is going to be alpha over it plus 1. By the way, if this is all really rusty for you, please don't worry about it. Come by my office hours or find another appointment to me, and we can help you remember all this stuff. I know it's a lot, and we're using it in a weird way. So we can take this, right, multiply the top and the bottom by it plus 1 over alpha, and we can get it plus 1 over alpha ct is our MRS. What's this telling us? It's telling us that we're willing to give up more of our child's future income for consumption today when our child has a higher future income and we have less consumption today. Seems reasonable, right? If I'm super hungry, I expect my kid to be a billionaire, I'm gonna, be happy to take a little bit out of their bank account, right? Or contribute less to their bank account. And then we've got this alpha here, which tells us that the less we value our child's future income relative to our consumption, the more we're going to be willing to trade our child's future income for our present consumption. Beautiful. So far, so good. And as we said, right, we're going to set this thing equal to our price ratio. So we're going to say it plus 1 over alpha ct has to equal 1 plus r, which is going to allow us to get one of our goods in terms of the other, right? So why don't we say, what's our it plus 1 going to be as a function of ct? Actually, let's do ct as a function of it plus 1. So we're going to say it plus 1 over alpha times 1 plus r is going to equal ct, right? In other words, this is our ratio of child's future income to our current income, or our current consumption, that's going to make us happy, right? Where we're not going to want to give up some of our consumption for a child's future income, or vice versa. So then all we've got to do is plug this into our budget constraint, right? So we're going to say ct plus it plus 1 over 1 plus r is going to equal it plus et plus 1 plus mu t plus 1 over 1 plus r. We're going to take this, plop it in for ct. So that'll give us it plus 1 over alpha times 1 plus r plus it plus 1 over 1 plus r equals it plus et plus 1 plus mu t plus 1 over 1 plus r. Lovely, lovely. So we can combine all of this, right? So we'll say this is really, we can multiply this by alpha over alpha, right? So then we can say 1 plus alpha over alpha times it plus 1 over 1 plus r is going to equal it plus et plus 1 plus mu t plus 1 over 1 plus r. Sorry, this is hard to do on a tiny board. And then we can get it plus 1, right? We're basically there, just by multiplying both sides by 1 plus r times alpha over 1 plus alpha. So we can say it plus 1 equal alpha over 1 plus alpha times it times 1 plus r plus et plus 1 plus mu t plus 1, not over 1 plus r at all. right? Because the 1 plus r's cancel. So what's this telling us? It's telling us that our child's future income is going to depend on how much we care about the child's future income, right? Alpha over 1 plus alpha is going to be bigger the bigger alpha is, times basically the size of our total family budget valued in the future, right? The total family budget available once our child becomes an adult. So after the my parents' income has vested, right, all the interest is accumulated, and when I no longer would have to borrow against my future income. Wonderful. And then to get consumption, right, I just plug this into here. So I'm going to say CT is going to equal IT plus 1 over alpha times 1 plus r, which means CT is going to equal alpha over 1 plus alpha times alpha times 1 plus r, all times 1 plus r IT plus ET plus 1 plus mu t plus 1, which is going to be, alphas cancel, right? The 1 plus r cancels with 1 plus r here. So this is going to be 1 over 1 plus r, 1 plus alpha, times IT plus ET plus 1 plus mu t plus 1 all over 1 plus r. Lovely. So there we go, right? We figured out for this family, right, given their child's future earnings without their investment, given the interest rate at which they can invest in their child, we figured out what the child's income is going to be as an adult, right, this thing here, and we figured out how much the family is going to consume in the present moment. Pretty cool. And again, right, if we think about what this means, it means the less we care about our child's future income, the higher our consumption today is going to be. Our consumption today is basically going to be some fixed fraction of our total family income, right, valued today. So our IT is not going to have an interest rate. We would have to borrow against that future, so it's going to be over 1 plus r. Now again, remember this is only the case for a household that's going to invest some positive amount in their child, right? So the other possibility is that CT is going to equal IT, and IT plus 1 is just going to equal ET plus 1 plus mu t plus 1. One last thing I want to figure out before I move forward is that this is how much our child's going to have as a future income. This is how much our family is going to consume today. How much are we investing in our child, right? In other words, how much of our parents' resources are going towards our future income? And how does this depend on the parameters we've laid out? So we can do this by remembering that our child's income at period t plus 1 is equal to 1 plus r yt, right, plus et plus 1 plus mu t plus 1. And our income in period t plus 1, as we said here, is equal to this, right? So what this is going to mean is that this thing here, alpha over 1 plus alpha times 1 plus r it plus et plus 1 plus mu t plus 1 has to equal 1 plus r yt plus et plus mu t. So as a result, right, we're solving for yt, so we can subtract et plus mu t from both sides. We can say then alpha over 1 plus alpha times 1 plus r it, right, plus alpha over 1 plus alpha et plus 1 plus mu t plus 1, right, minus et plus 1 minus mu t plus 1 equals 1 plus r yt. So from here, right, mush all this together, right, so alpha over 1 plus alpha et plus 1 minus et plus 1, well this is 1 plus alpha over 1 plus alpha, right, times all this whole thing. So what this is going to leave us, right, negative 1 plus alpha is just going to be negative 1. So we'll say alpha over 1 plus alpha times 1 plus r I t minus 1 over 1 plus alpha times et plus 1 plus mu t plus 1 is going to equal 1 plus r yt. So that means, wait for it, right, that yt is going to equal, right, we just divide both sides by 1 plus r, alpha over 1 plus alpha times it minus 1 over 1 plus alpha times et plus 1 plus mu t plus 1 over 1 plus r. So this is actually really important and really cool, right? Because what this is telling us is, the richer our parent is, the more they're going to invest in our future. Reasonable enough, right? They've got more resources. The more our parent cares about our future income, the more they're going to invest for our future income. But the better off we would be with our investment, right? The luckier we are, the less our parent's going to invest in our future income. So what this is basically saying is that parents' investment decisions are kind of like a mush factor or a brake on how good or how bad our life is going to be on the basis of the things that make us lucky. If we get, really good breaks, right? We get great investments from outside of our family. We've got really good job opportunities, right? Things are getting better and better every year. Our parents are going to respond by saying, you know what? I don't need to invest so much in my children. We can all enjoy our lives more now, right? We can all consume more as a family today. If things look really terrible for you, right? Your outlook looks really bad. Your parents are going to say, gosh, my kids are going to be really, out of luck if I don't do something. So I better ramp up my investment in my kids. Cool. And then we said, right, this is all true if yt is greater than 0. The last finishing touch on this is talk about what will happen when yt is not greater than 0, when that'll be, which is to say what's going to happen to make our optimal choice to have our consumption today just be equal to it and our child's future income just be their luck. Essentially what needs to happen here is that our marginal rate of substitution be greater than 1 plus r at this point. So we'll say yt equals 0 if our MRS is greater than 1 plus r when CT is equal to IT and IT plus 1 is equal to our luck. What's our MRS? We said that our MRS is going to be right, IT plus 1 over alpha CT. So this is going to tell us that if ET plus 1 plus mu t plus 1 over alpha times IT is greater than 1 plus r, we don't invest. Just kind of a finishing touch on this model is that if our family is low income enough, right, our IT is low enough, my parent is low income enough, and if I'm likely to be well enough off in the future, right, plus depending on how much my parent cares about my future income, my parent might decide that we're not going to invest at all. So for very low income children, you might not get any investment from your parent. Okay. There's one last piece that we need before we can take this model of parent investment in children and turn it into a model of intergenerational mobility. And that is that we said that this ET plus 1 represents aspects of a child's welfare or well-being that can be inherited from parents, right, transmitted from parent to child, without the parent having to make an active sacrifice. Things like speaking with a similar accent as your parent, or inheriting some of your parent's social networks, or inheriting your parent's race, right, and the advantages or disadvantages that come along with that. So the last thing that we need to do is we need to say how your endowment, right, your ET plus 1 is going to depend on your parent's endowment. And essentially what we're going to do is we're going to say some part of this is inherited and some part isn't, right? You inherit your parent's endowment but with a little bit of a fuzz factor or noise. So we'll say ET plus 1 is going to equal 1 minus sigma times E bar, which is just the average endowment for everyone, plus sigma times ET, right, your parent's endowment, and then plus what we'll call, I believe this is a new t plus 1, which is essentially your idiosyncratic change in all of these things, right? Some people grow up with a fairly low quality or less lucrative social network and then make some really, really highly placed friends that they're going to be able to pass on to their children. That's going to be in this new. So then finally, when we take our it plus 1, we can lump this in here. So we can say it plus 1 can equal alpha over 1 plus alpha times 1 plus r it plus 1 minus sigma e bar plus sigma et plus nu t plus 1 plus mu t plus 1 all over 1 plus r. I'm going to rearrange this a little bit to say it plus 1 is going to be a function of 3 things. It's going to be a function of your parents' income. It's going to be a function of inherited advantages from your parents. Sigma et over 1 plus r. And it's going to be a function of your random idiosyncratic luck. Stuff that you don't get from your parents at all. Right? So this is parent income. Parent endowment. And not related to parents. The cool thing that Becker says is that as long as alpha is small enough, particularly if alpha over 1 plus alpha times 1 plus r is less than 1, and sigma is small enough, right, if it's less than something like 0.8, 0.9, even really, really large differences in incomes across households, given enough time, are going to disappear. He says for reasonable assumptions about what these values are, wealthy and poor households are going to switch places or converge to each other, usually within a few generations, if we take this model. And what this should tell us is when we don't see that happening, right, that's either going to tell us that there's things missing from this model, like inheritance from grandparents in addition to parents that slows down the process of intergenerational mobility, or sorts of inherited caste advantages or other things that don't disappear over time. Okay, wonderful. So this is the Becker intergenerational mobility model when we just have one form of parent investment, right? When we just have investment through YT. The last thing we're going to do today, and I know your heads are probably already spinning a little bit, this is a lot of math. The last thing we're going to do today is we're going to think about a modification of this model where parents can invest either by giving their kids inheritances or giving their kids money, or by investing in their kids' human capital.